Hello guys, we have a problem and it is to name this compound. So first of all, if you think you can name it before we forge ahead, you can pause the video and try it out. Now, this compound is an organic compound and it is the skeletal formula or the skeletal structural formula of the given organic compound. What we mean by skeletal formula is that you can see the hydrogens, the carbons are ignored. This is just like a diagrammatical representation of the compound while ignoring the hydrogens and the carbons in the compound. So how do we know where the position of the carbons and the rest are? It's simple. Now, if you have a structure like this, if you have a skeletal formula of an element, just know that each angle represents a carbon atom, and then the first point also represents a carbon atom. For instance, now in this compound, there is a carbon atom here, there is another one here because there is an angle here, there is another one, another one, another one, another one. And then the starting point, like from here to here, the starting point here, there is a carbon atom. So this is an angle, there is a carbon atom, and this is a starting point, there is a carbon atom here. There is a carbon atom here, there is a carbon atom here, and there is a carbon atom here. And there is also another carbon atom here. And then second thing we should notice is that this compound is a cyclo compound. A cyclo compound is a compound that is closed shaped. There is no opening, right? So if you can see, this particular shape is like a hexagon. It is closed shape. It is like a polygon. So it is a cyclo compound. We call such compounds as cyclo, right? So the first thing first, we are to identify the longest chain. Now, because this is a cyclo compound in this case, or before then, if you still don't understand this, let me briefly write this exact formula for you down here so that at least you can have an idea of what we are talking about, right? So here is the same thing as saying CH, the hydrogens are ignored. So here is the same thing as saying CH2, then CH, 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 then CH2, CH, then like this. Then here we have CH3 representing this. Then here, this attachment, we have CH2 and then CH3. And here, we first of all have CH2, then another CH2, then another CH3. And then here we have CH3. So this compound is exactly this one. So you see, it appears to be bigger here. That's the need for skeletal formula, right? So let's go back. If you don't understand this, you should understand this. If you don't understand this, you should understand this. So the first thing is to name the carbon atom, right? So this is a cyclo compound. So the longest carbon chain will just be the cyclo compound here, which is 6 carbon atom, which has 6 carbon atom. 1, 2, 3, 4, 5, 6. So there are 6 carbon atoms in the cyclo compound. So which means this point, this point, this point, and this point are substituents. They are substituent group. So we'll name the carbon atom in such a way that the substituent group will have as small number as possible. So if we start from here and go this way, we have 1, 2, 3, 4, 5, 6. So the substituent will be on carbon number 1, 2, 3, 4. And I think that will give it the smallest name possible. And we can also start from here, 1, 2, 3, 4. That's clockwise or anti-clockwise. So should we go from this point 1, 2? Should we start numbering from this point 1, 2, 3, 4, 5, 6, or we should start from 1, 2, 3, 4, 5, 6? So which one takes the priority? Since they are going to give us almost the same thing, so which one takes the priority? Now, first thing first, if we start from here, let's start from here. Let's start counting from here as the first carbon atom. So on the first carbon atom, we have, this is a CH3 group, as you can see here. So this is methyl. And then on the second carbon atom, there is an ethyl substituent. This is ethyl. The second carbon atom, there is an ethyl substituent. And then on the third carbon atom, this is 1, 2, 3. 3 carbon atoms as substituents. That's propyl. There is a propyl substituent. And then on the fourth carbon atom, there is a methyl substituent, right? And if we start from this way, now let's do the other round. Then on the first carbon atom, there is a methyl substituent. On the second carbon atom, there is a propyl, this one now, propyl substituent. On the third carbon atom, there will be this one now, an ethyl substituent. And then on the fourth carbon atom, there will be a methyl substituent. So if you see all of them are 1, 2, 3, 4, 1, 2, 3, 4, but only one is correct. Now, if you have substituents arranged like this in such a way that whether you start numbering from left to right or right to left, the numbers won't change, you give priority to the alphabetical order. So if we start from here, right, we start from here, whether we start from here or here, the one methyl still remains. Then you come to the next option, 2 ethyl. So this is E, while this is P. So 2 propyl violates alphabetical order, while 2 ethyl conforms to the alphabetical order. So which means the second carbon atom will take the priority of the ethyl. So we'll start naming 1, 2, 3, 4, and not the other way around, because we want to give the ethyl, the second carbon atom, the preference of having the ethyl based on alphabetical order. So this will now be the correct thing. So 1, 2, 3, 4, 5, 6 carbon atoms is hexane. Hexane. But it is not a normal open chain hexane. It is a cyclo. We have to indicate the cyclo. So it is a cyclohexane. So this is the parent name of this compound. So let's come and fix this attachment. So in fixing the substituent, we start alphabetically. So E comes first. So we will have a 2. We'll have, sorry, or let me use a fresh page. We'll have 2 ethyl. And then what next? Between M and P, M comes next. So we have 1, 4 dimethyl, and then ethyl, 3 propyl, then cyclohexane. So the name of this compound is 2 ethyl, 1, 4 dimethyl, 3 propyl cyclohexane.